left with few slides of chapter 2, and we talked about the 4 conditions, right? So let's just recap a little bit of the conditions that we talked about. So we talked about that it should be linear in parameters, right? If you guys recall that for the simple regression model, as we have did the exercise on the practical exercise in the lab session, the first thing for a simple regression model that it should be linear in parameters, right? And the second assumption, it's should be like random sampled, right? And random sampling, that means the data is a random sample and it's drawn from the population, and each data point therefore follows the population equation, right? And there is an example, like the discussion of random sampling in wage and education. So for example, the population consists of all workers of country A. So in our World Bank data set, we can think about if we are analyzing, let's say, for France. So we have to consider, for example, the population of all workers of country France, right? If you are doing a cross-sectional data, right? And in the population, a linear relationship between wages and years of education holds, right? So this should be linear in form, like one of the assumptions, and draw completely randomly a worker from the population. So if you are you want to make a linear model or a simple regression model, the sample should be drawn from a random sample. Okay, luckily for us, the World Bank data sets, it's already randomly sampled. You might say that how did they collect all the data for a particular country, right? Do you think they individually sampled each of them? It's not possible, right? Because a country has 100 and let's say United States, they have 320 approximately population million, 320 million, right? So they did it randomly. We don't have to worry if we are using the World Bank data set. The fourth point is that the wage and the years of education of the worker drawn are random, because one does not know beforehand which worker is drawn, right? So they have drawn randomly, they didn't just go to a particular area and collected the data. I mean, they went to several areas, okay? Offices or let's say construction sites, everything. In fact, you guys will get where the data is collected, they have some information regarding that in their website, right? And so these are the steps that they have followed, and we basically covered this in the last class. Just I'm going through some of that. And if you see, in a simple linear regression model, it's usually the best fit line. Okay, so they have collected, let's say, data for several points. Okay, I'm just circling there. And the simple linear regression, what it does is it estimates the best linear point. Okay, or in other words, we can also call it the best fit line, right? So the ideology is similar to a best fit line. And assumption number 3, this is also important. There should be sample variation in the explanatory variable. Okay, so the explanatory variable that we are choosing should have some sort of variation. For example, in this class, if I want to see the class performance of students, if all the students are getting the exact same grades, will there be any variation in the grading? If all of you guys are either getting full score in the exam or all of you are failing in the exam, then there's not much variation, right? And I cannot model the if everyone is like, if I draw, like, let's say if I draw a model, if all of you guys are getting like, let's say, okay, all of you guys are getting like the same score. Let's say all the points will be cluttered here. Then can I form a best fit line? No, right? So there should be variation in the part. So variation in the explanatory variable, right? So values of the explanatory variables are not all the same. Otherwise, it would be impossible to study how different values of the explanatory variable lead to different values of the dependent variable. So in the lab session, we did like total health expenditure, how that is dependent on like BMI, the body mass index, and like, let's say, smoking, right? So smoking. So if all of people's body mass weight index were exactly same, it's a problem. There is no variation. So the assumption 3 is that there should be sample variation in the explanatory variable, right? Is it getting clear? Because we did the practical exercise and now we are talking about the theoretical aspect, right? Is it easy to follow for all of you guys that there should be sample variation, right? And the fourth assumption is zero conditional mean. That means the error term should not like ui given xi should be 0, right? What's ui? Ui is the error term, right? And it should not influence the explanatory variables. Explanatory variables meaning that the independent variables, whatever is on the right hand side, it should not influence. Like usually the equation we also have a u term, right? So this is the left hand side, the total health expenditure, and right hand side is the whatever explanatory variables we are selecting for the model, right? So for my case, I chose body mass index, BMI, smoking, what was the other variables, like access to clean water, right? You guys recall like what we selected for the lab session? So those were the explanatory variables or the independent variables. Of course, you guys are free to choose your own variables. In fact, I want you guys to choose your own variables and own database. Like some of you guys want to do project on unemployment. Like I remember in the intermediate macro class, some of you guys did with unemployment and things like that. You can analyze about environment, like how carbon dioxide emission. Of course, for a simple linear regression, we all need the 4 conditions. And the 5th condition also I will talk about today, which is the assumption that they are homoscedastic in nature. Okay, it should be homoscedastic. Right? So theorem 2. So when all these 4 conditions like are followed, in fact, like they follow the principle, then the estimated beta hat. Okay, beta hat means it's an estimated, would be equal to the population beta naught. Okay, so beta naught hat, expected value of beta naught hat should be exactly equals to beta naught. Okay, once these 4 conditions are are followed, or like so similarly estimated beta 1 hat would be equals to beta 1. Okay, so I can ask like a conceptual question, like when can the sample estimate converge to the population estimate? So only when these 4 conditions are met. And you guys have, maybe I will say that state the conditions or something like that. So you have to state that random sampling, there should be variation in the explanatory variables, then the ui given xi is 0, right? And they should be linear in like they should have a linear relationship. Okay, so interpretation of the unbiasedness, estimated coefficients may be smaller or larger depending on the sample that is the result of a random draw. Okay, of course we won't get the exact estimate because in that case we have to sample all the population, right? So it can be smaller or larger. So when you are writing your paper, make sure you mention that the estimates that we are estimating is subject to like the coefficient is subject to like some sort of bias because it's collected from a sample, right? And however, on average, they will be equal to the values that characterize the true relationship between y and x. The World Bank dataset is extremely like neat and clean. They have like assumed all these 4 conditions. Otherwise, like lot of people are using their dataset. All right, so they have assumed these all 4 conditions, and on average means if sampling was repeated, that if the drawing the random sample and doing the estimation was repeated many times. Okay. Again, they're just reiterating the point that in a given sample, estimates may differ considerably from true values. Okay. You guys can mention when you're writing your term paper, right? In fact, I will give you guys my own term paper which I have written for the graduate course, and I'll give some instructions like what you should follow, like how many pages it should be. Like I am expecting you guys should cite at least 8 to 10 papers. Okay, you do like read 8 to 10 papers, do a literature review, explain your variables, and like cite them, because if you don't cite, then once we put the paper in like a plagiarism checker, it will show that you have plagiarized the work. In fact, you actually didn't plagiarize, maybe because you might have just cited them but forgot to use citation properly. So that will show that you have plagiarized your work. Okay, so the plagiarism checker, it should be less than 10%. Okay, they say less than 15%, but for good practice I want to set it to 10%. All right, so do not just copy the words from the papers. Okay, paraphrase it in your own words. All right. Okay, so the last assumption, the fifth one, is the homoscedasticity. So variance of the OLS estimators. So depending on the sample, so the estimates will be nearer or farther away from the two population values. So again, they are saying the same thing, right? And how far can we expect our estimates to be away from the true population, or like values on average? So sampling variability is measured by the estimator's variances. So, and this is the fifth and final assumption. So this is the value of explanatory variable must contain no information about the variability of the unobserved factors. Okay, it should not contain any information about the error term. So your explanatory variables, for my case it was BMI and smoking and access to clean water. They should not contain any information about the variability of the error term. If that is the case, then it's not homoscedastic. And if it's not homoscedastic, we cannot do a cross section. In that case, you cannot do cross section data. Okay, you cannot do if it's not homoscedastic. Okay, if not homoscedastic. And actually, I didn't teach this like to you guys. In Stata, you can check the homoscedasticity. Okay, and the easier way to do that is go to your command prompt. Like after you clean the cross section data and you have like you cleaned it, removed the double dots with single dots, right? You have destringed all the variables, you have encoded the variables. Once the cleaning part is done, you run your regression, then type het, HETTEST, okay, het test in Stata, and it will tell you if your cross-sectional data is homoscedastic or heteroscedastic. So if it is heteroscedastic, then we cannot do a cross section. and in that case we have to go to panel data, okay, if it's not homoscedastic in nature. But in most of the cases you will find that it's homoscedastic, especially if you're using the World Bank databases. Why? Because they have like done the sampling using like all those 4 assumptions, right? It's in linear form, random sampling, there's variability in the data, in the explanatory variables, and it's not correlated with the error term. The conditional, zero conditional mean is 0. Okay, I can ask a question, what is the zero conditional mean? So these are theoretical stuff, and if you guys do the homeworks that I have assigned, which is due this Wednesday, November 8th, things will get clear. Right? So is it clear to all of you guys? All these 5 assumptions, I'm actually going a little slow on this because this is what you guys need when you are writing your paper. Or if you take a graduate level course, the foundation is very important. So if you see a graphical illustration, so all this variability would be, like there is like unobserved factors does not depend on the value of the explanatory variable. So they don't contain any information about the unobserved factors or the UIs in this case. Okay? Your explanatory variable should not have any information on the unobserved factors. Look at the second graph. Now, can anyone tell me what's the difference? See, there's this variable has a lump, right? So that means they contain some information about the UIs. And in that case, that means they are, the zero conditional mean is not 0, right? The 4th assumption, and also it's heteroscedastic in nature because they contain information about the unobserved factors. So, and also this one is like less. It's not like symmetric throughout. It should be symmetric if, so this is heteroscedastic. Okay, you can check it graphically from your data set. So under assumption 1 to 5, we will get the variance of beta 1 is equals to sigma square over SST, right? And variance of beta 1 is this, and variance of beta naught is sigma square over n and sum of xi squares over SST. Xi square means the independent variables, your explanatory variables, right? So these are your explanatory variables, right? So the variance of ui does not depend on x, that is equal to the unconditional variance. So this is the assumption for homoscedasticity, okay? It's not heteroscedasticity but homoscedasticity, right? Homoscedasticity. And one could estimate the variance of the errors by calculating the variance of the residual in the sample, okay? Unfortunately, this estimate would be biased, okay? So that's the problem when you are estimating the variance by calculating the variance of the residual in the sample, okay? So the sample residual means the part that is not explained, the unexplained part, right? Residual is the unexplained part, and explained part is actually the explanatory variables, right? If you guys attended the last class, or you can watch my video that's uploaded, right? I have recorded that session in the previous class. You will guys have a clear idea. In fact, I want you guys to focus more on this, okay? I'm expecting that you guys would do like a cross-sectional data analysis using the World Bank data set, okay? If you want to go advanced, you can do panel, okay, and more advanced than instrumental variable. Okay, in that case you guys need to make a appointment that yeah, I want to go beyond panel. In fact, panel is already a lot of like for an introductory class is more than enough. The panel data, like if you write a project on the panel data, right? So this could be a potential midterm question. All right, I have given a star. I might webcast this video online as well. Okay, and let's look at the last part. An unbiased estimate of the error variance can be obtained by subtracting the number of estimated regression coefficients from the number of observations. Okay, so we have to subtract the number of estimated regression coefficients from the number of observations. So in this case they have subtracted 2. Probably they have 2 number of estimated regression coefficients from the number of observations. Okay, that's why there is a -2 here, right? If you have estimated maybe 5 estimated regression coefficients, then you do n minus 5, right? So this is also like a key point. Right, and of course you guys can write down these formulas like the midterm. In the final you guys should make a note of all these formulas, like the standard error. If I tell you guys find the standard error, I have to give you guys at least the sigma square hats or the SST values. Only then you can find the standard error of beta 1 hat. Okay, and standard error of beta naught is this formula, right? So you guys can write the formulas down. Okay? So that's about the simple regression model.